Hi, and welcome to the tutorial for the QA tool in Cortex. Today, we'll explore the QA tool and learn about its different modules and uses. If you're not familiar with any particular element we cover in this tutorial, visit tutorials.mtifilm.com. Keyboard shortcuts for all of the Cortex tools are available in the Help menu, and as we go through the tutorial, they will appear on the screen for easy reference. Press Shift F1 at any time while Cortex is open to access the manual. Let's get started. The QA tool contains modules to help you verify the quality of your media. The Dead Pixel module is where you work with dead pixel detection and, if you have the Enterprise edition of Cortex, the dead pixel correction aspects of the QA tool. Cortex detects dead pixels on a per-clip basis, so using it on set can help determine whether a camera has sensor issues. In post-production, it can detect shot breaks or merge an EDL into previously edited material for the purpose of detection and correction prior to delivery. Due to the importance of dead pixel detection and correction, this module is covered fully in a separate tutorial that can be found at tutorials.mtifilm.com. The Graphs module provides the ability to analyze video and audio levels and composition bit rates with results shown in a graphical display. When analyzing video based on a composition containing desired media and selecting the Analysis tab, the evaluation is performed on a per-deliverable basis so that an accurate representation of levels as processed through the deliverable color pipeline can be produced. To change the deliverable pipeline being used for the analysis, choose a different tab above the player window. If you want the analysis to apply directly to the source without regard to any particular deliverable, click Analyze from Source. Analyzing from source is the recommended practice. If you want to analyze a specific part of the composition, set your in and out point timecodes here. Or you can use existing marks on the timeline and click here to mark your in and out. Otherwise, Cortex will analyze the entire composition. Then set your source and target color spaces. If your composition media is letterboxed or pillar boxed, enable the region of interest, or ROI, and set the mask to the edge of the active picture. Zoom the picture by using the mouse wheel so that you can accurately place the mask. The ROI is used to define the active picture boundaries for the analysis. The mouse wheel zoom is only for viewing purposes and does not affect the actual framing. Now analyze your composition. Once the analysis is complete, you can choose how to display the results. If the composition being analyzed is HDR, make sure this option is selected. The scale of the graphs are set here, with options for viewing the analysis results as code values or IRE percentages. If the media is HDR, Cortex has options to view the analysis in nits, either as fall and CLL values or minimum and maximum values. When the scale is set to view fall and CLL values, the threshold field allows the user to set the parameters by which discrepancies in the analysis are reported. Related to the video graph is the Discrepancy tab next to the player window. This tab will list all of the instances where the analyzed video falls outside of the desired range, which is set in the Discrepancy tab and is relative to the scale setting in the graphs area. If your composition is SDR, the discrepancy range options will be listed as code values. Double-click on any discrepancy to jump to that frame in the composition. The Bitrate tab displays the analyzed bitrate of the composition. Minimum, average, and maximum bitrate values are displayed at the top, along with the current bitrate when the media is playing. The Loudness tab allows you to analyze the audio based on the two broadcast standards, EBU and ITU. To begin an audio analysis, click on the Audio button to reveal the audio options. In a standard composition, the audio is analyzed through the configurations determined by the deliverable. In an Imf composition, you must select the configuration you would like to analyze or the scratchpad. If you would like to ignore a section of the timeline, such as the tone at the head of a delivery, set an in and out mark. Last, select the standard. Once the analysis is complete, a graph of the composition will appear reporting the current integrated loudness, the current momentary loudness, and the current true peak. In the Discrepancy tab, excursions are reported based on a target loudness with a plus or minus threshold. Double-click on a discrepancy to find it in the composition. If you've done a dead pixel detection on the composition, the dead pixel candidates will appear on the graph here. with each color channel's pixel count represented as appropriately colored lines segment by segment. All information in the graphs can be exported via a QA report. Choose the desired output path for the report and its name. Then select or deselect the desired information to be included in the QA reports, including the discrepancy and threshold levels for audio and video. Then save the report. The Scope tab displays waveform and vector scope monitors as well as a color gamut diagram, identical to the Color tool. It also contains audio VU meters similar to those next to the player window. Every audio track in the selected audio configuration will be active, each with the ability to mute or solo for further verification. To mute a track, click its monitor button. To solo a track and mute all of the others, press Shift and click its monitor button. To the left, you will find the Loudness Meter, which reports values based on the standard you select in the Audio Analysis tab. The Performance tab displays relevant system processes and performance data during playback. These bars represent disk reading time, decoding time, read and decode time, and GPU processing time, all processed in milliseconds. Other relevant bitrate data is also displayed below the indicator bars. While playing media, Cortex displays the dynamic information with the visual indication of the minimum performance measure needed to play back the media in real time. If the performance indicator bars are green, then the playback and performance are exceeding the minimum. If any of the three criteria falls below the minimum need, but doesn't affect the ability to play back the media at its correct frame rate, that bar will turn yellow to indicate the issue. If any of the categories being measured cause playback speeds to drop below real time, its bar will turn red to indicate a cause for any playback issues. The Imf Validation Tool uses the latest version of the Photon IMF validation software released by Netflix. It validates that all required assets are present in an imported IMF, verifies hashes, and can export a PDF report of the results, including any errors. In the Dolby Vision Validation tab, Cortex can verify Dolby Vision metadata based on the Metafire application used by Netflix. Select the composition you would like to validate and click Validate. Cortex will produce a readout of the reports, which can be also saved as a PDF for distribution. And that's the tutorial for the QA tool in Cortex. To learn more about Cortex, please visit tutorials.mtifilm.com. For support, to submit a help ticket, or to find other useful information about Cortex, please visit forum.mtifilm.com. Thanks!